Okay, so now we'll take a look at L'Hopital's rule. Now, this is L'Hopital's rule. It says, let f and g be functions differentiable on an open interval from a to b. So on the x-axis, we have an interval from a to b. F and g are functions that are differentiable on that entire interval. And this interval, a to b, contains a number c. So on this interval from a to b, we have a value c. These functions are differentiable on the interval from a to b, except possibly at c itself. We want to assume that the derivative of g on the entire interval is non-zero, and that's except possibly at c. And if that's all true, then if this limit gives you one of these indeterminate forms, either 0 over 0, infinity over infinity, negative infinity over infinity, infinity over negative infinity, or negative infinity over negative infinity. So basically, either two zeros in a fraction or two infinities in a fraction somewhere. If you get one of these indeterminate forms, then this limit of the original, the quotient of the original two functions, is actually equal to the limit of their derivatives. So that means if you can't find the limit of the original functions, you can take both derivatives and take the limit, and the limits will be equal to each other. That's, of course, provided this limit over here is either something that exists or is infinite. So let's take a look at an example here. Let's look at the example, the limit as x approaches 1 of the natural log of x squared over x squared minus 1. All right, now in order to calculate this limit, well, we first do direct substitution, and we get the natural log of 1 squared over 1 squared minus 1. The natural log of 1 is 0, and 1 squared minus 1 is also 0. So I get this indeterminate form. Since I have this indeterminate form, it says if the limit gives you that indeterminate form, then we can use the derivatives instead. So that means that this limit, provided I see that f of x is equal to the natural log of x squared, and g of x, the denominator, g of x is equal to x squared minus 1. From the formula, f of x is the numerator, g of x is the denominator. I need to find their derivatives. Well, let me see. I can rewrite f actually. F of x is actually 2 natural logs of x. Let me rewrite that here. F of x is actually equal to 2 natural logs of x. And if I want the derivative, f prime of x is equal to, let's see, 2, and then the derivative of the natural log is 1 over x, so I get 2 over x. The derivative of g, g prime of x, is equal to 2x. So that this limit, this original limit, is equal to this limit if it exists. The limit as x approaches 1 of, well, f prime of x, the numerator, is 2 over x. G prime of x is 2x, which is equal to the limit as x approaches 1 of, well, I have 2 over x multiplied by 2 over x over 1 is, the reciprocal is 1 over 2x. The 2's cancel out, and let's see what we have here. In this case, we will get, this is equal to the limit as x approaches 1 of 1 over x squared. And that limit is equal to 1. Now, since that limit exists, that tells me, since this limit down here exists, is the limit of f prime over g prime. Since the limit of f prime over g prime exists, that means it's actually equal to the limit of f over g. So that I can say the limit as x approaches 1 of the natural log of x squared over x squared minus 1 is equal to 1 by L'Hopital's rule. So by L'Hopital's rule, this is the limit. All I had to do was take the derivative of the numerator, the derivative of the denominator, and then proceed to take the limit of that quotient. So that is L'Hopital's rule. Let's take a look at one last example. Alright, let's take a look at this example here. The limit as x approaches infinity, this is an infinite limit, the limit as x approaches infinity of the natural log of x over x squared. Well, direct substitution yields the natural log of infinity over infinity squared. Well, the natural log of infinity, the natural log is an increasing function. Natural log is an increasing function, so the natural log of infinity is infinity. Infinity squared is also infinity, so I get the indeterminate form, infinity over infinity. Whenever you get that indeterminate form, you can also use L'Hopital's rule. And L'Hopital's rule says this limit is equal to the limit of the derivative of these two functions, the quotient of the derivative of these two functions, if that limit exists. Well, the derivative of the natural log is 1 over x, and the derivative of x squared is 2x. So once again, this is the limit as x approaches infinity of 1 over x times 1 over 2x, which is the limit as x approaches infinity of 1 over 2x squared. And that is equal to 1 over 2 times infinity squared, which is 0. So this limit is equal to 0, which means that the original limit, the one I'm asked to find, is actually also equal to 0. So from L'Hopital's rule, since this limit is equal to infinity over infinity, that indeterminate form, I can take the derivative of the numerator and the denominator and take the limit, and it should equal the same number. So that means that the limit as x approaches infinity of the natural log of x over x squared is equal to 0.